Hello everyone. Today we are going to solve one example for a truncation error, a general example that how you can treat these truncation errors using Taylor series, and then even find higher order finite difference approximations by by playing with these truncation errors. Okay, so let's get started. So the topic this lecture is gonna be truncation error example. So the example that we have states find the truncation error, or we can also say order of accuracy of the advection diffusion equation with a variable downstream weighting scheme for the advection term and central difference for the diffusion term. Okay, so this is the problem statement, and the equation that we have is an advection diffusion equation. So it's going to be v du over dx minus d square u over dx square equals to 0. Okay. So this is a problem statement, and the first thing that we need to do is to write the approximation based on what the problem asks us. So let's show the answer. So let me write it here. Answer. So the first step that we need to take is to show this equation based on the approximation that the problem asks. So v du dx minus d square u over dx square equals to 0. Right, so this is the equation. So I want to approximate this at xi, point xi. Okay, the whole thing. So this can be written as v, and for this, the problem says for the advection term, which is this term, I need to use a downstream weighting scheme and central difference for this one. So for the first time, I'm going to use this. It's going to be alpha ui. This is the variable weighting scheme. It's going to be ui minus 1 over delta x plus 1 minus alpha ui plus 1 minus ui minus 1 over 2 delta x. And if you remember, this was the variable weighting scheme that we talked about it last time, right? So this scheme, a variable weighting scheme. And then the second term is gonna be the diffusion term. We are gonna use a center difference, right? A center difference scheme based on the problem here that mentioned that. So it's going to be minus d ui plus 1 minus 2 ui plus ui minus 1 over delta x squared equals to, the whole thing equals to 0. So just as a reminder, the central difference scheme was this scheme that we introduced last time for the second derivative, right? So I just used it here. Okay. So this was what the problem wants us to solve. Like, this is the equation that the problem wants us to solve. And now we want to find what is the truncation error for this approximation. Okay, is it order delta x? What is the order of accuracy? Is the order delta x? Is it order delta x squared or what? Right. So we want to find it. It's a general way. Like, if you have an approximation, a finite difference approximation is given to you, you can use this method, which is by using this Taylor series, okay? And then you can find the associated or the corresponding truncation error. Okay. So what I want to do is I want to, first, I'm going to define, just for simplicity, du over dx as u prime. Okay, so this is just a notation for simplicity. And then I'm gonna use Taylor series. So use Taylor series. So for the first one, I'm gonna just factor out alpha and delta x for the first term. So I'm gonna write it v alpha over delta x. And then I have the first term, which is ui. And for the second term, I'm going to use Taylor series. So I'm going to describe it as ui. So I'm going to have ui then it's going to be the second term, which is going to be xj minus xi. Right, so it's going to be, because now is I minus 1, so I'm going to have minus delta x, and you can just calculate it yourself because we have done it before, and then multiplied by u prime I, the first derivative, and then we have the second term, which is going to be delta x squared over 2 u double prime I minus, then we have the third term is going to be delta x cubed over 3 factorial, and then we have u triple prime I, and plus other terms, right? So I'm not going to go further, just these terms. So this is the first term, which is this one, right? I just wrote it here. So let's go to the second term, which is this one. So I'm going to write it as plus v1 minus alpha over 2 delta x multiplied by, so instead of ui plus 1, I'm going to again represent everything based on ui, so I'm going to use Taylor series. So it's going to be ui. Now, because we are 1 point ahead, so it's going to be plus delta x rather than minus delta x. So plus delta x u prime I plus delta x squared over 2 u double prime I plus other terms, and then minus ui minus 1 is going to be exactly like this that we found. So it's going to be ui minus delta x u prime I plus delta x squared over 2 u double prime I and other terms, right? Okay. So this is the second term, and now the last one, which is going to be the diffusion term. Let's do that. So I'm going to write it as minus d over delta x squared times, so the first term is going to be again this ui plus 1, the second term is going to be ui, the third term is going to be this. So let me just write them down. So I have ui plus delta x u prime I plus delta x squared over 2 u double prime I minus 2 ui, this term, plus ui minus 1, which is going to be this term. So I'm going to just write a ui minus delta x u prime I plus delta x squared over 2 factorial or 2 u double prime I. And here we have other terms I didn't write, and here we have other terms, right? Okay. So this is going to be my approximation based on the Taylor series. And now let's see what we can say. So the first thing is, in this equation, ui's are going to cancel out. In the second equation, here, ui's are going to cancel out here as well. And in the third equation, again, ui's are going to cancel out. And also, interestingly, u prime i's are also going to cancel out. So the first derivative terms are going to also cancel out. And so I'm left with this equation, a simpler form, which I'm going to write it here. I'm going to get V alpha for the first one. And then I'm going to bring the delta x inside. So I'm going to just put it here. So V alpha times u prime I minus delta x over 2 u double prime I plus delta x squared over 3 factorial or 6 u triple prime I minus other terms, right? For the second equation, I'm going to have plus v 1 minus alpha. I'm going to have u prime I. I'm going to divide everything by 2 delta x there. So I'm going to have u prime I again, plus the second term, if you calculate, add these two together, it's going to be delta x squared, and then multiply it by 2 delta x, you are going to get delta x squared, delta x over 2. So I'm going to get, minus, let me see, I'm going to get plus, yeah, so, sorry, these two terms are gonna, yeah, that was for the first term. So these two terms are gonna cancel out again. Let me see, yeah, I don't know why I didn't do it, so I had to write it here. So these two terms are gonna also cancel out. Okay, so, and then the third term is gonna remain, which is gonna be delta x squared over 6 u triple prime, which I haven't written that, but if you write it, you will get it, u triple prime. And then I'm going to have the fourth term is going to be delta x to power 4 over 5 factorial. And I'm going to have u 5 I plus other terms, right? Okay. And then the third one, I'm going to have d multiplied by, so the first one is u double prime I, if you just add them together. And then the next one is going to be delta x squared over 12. If you calculate that, it's going to be u 4 I and then other terms. Okay. An interesting thing, so now let's just rearrange the terms and see what we get. If we rearrange the terms, we are going to get v. So just add these two terms together. You're going to get v alpha u prime plus v1 minus alpha u prime. So if you just factor u prime I, you are going to get vu prime I. The first one is going to, you are going to get 1, and then the second one, you are going to get, let me just check. No, the first one you are going to get alpha, and then the second one you are going to get 1 minus alpha, right? So it's going to be just 1, right? These two are going to cancel out, so you are going to get just 1. So I will just write it as vu prime I. Then we have du double prime I. Then the next term that I have is v alpha delta x over 2 u double prime I plus, then the next term is, and I write it based on the order of delta x, so it's going to be v delta x squared over 6 u triple prime I, and then I have v alpha delta x cube over 24 u 4 I, and you can calculate this. And I haven't written all of them, but I'm just writing the full the final solution. And then I will have v delta x to power 4 over 5 factorial u let me make sure, no, it's gonna be 5 u 5 I, and then finally you have minus d delta x square over 12 u 4 I, and you have other terms that I'm not gonna write them. Okay, so this is just these terms, the first terms. Okay, so now very interesting thing happens now when we write this down, and that is, if you see the original equation was vu prime minus du double prime equals to 0, and that equation just emerges here. So it's very interestingly emerges here. So this is just our governing equation. And this one, whatever is on the right on the right is just a truncation error of this approximation, right? So this is the error of this approximation. So it's truncation error. And as you see, it is order alpha delta x from here, you see, and delta x squared, right? Based on this solution, we can see that the smallest terms, the order is going to be alpha delta x and delta x squared. So this means, what does this mean? This means if alpha is 0, we have if alpha is 0, it means that we only have a central difference scheme right here for the advection term, right? Central difference scheme for the advection, and also central difference scheme for the diffusion, right? If alpha is 0, then the order of accuracy of this is delta x squared. But if alpha is not 0, then we don't know. We don't know what is the order of the accuracy. So the question is whether it's going to be delta x, right? So if alpha is not 0, then we don't know that, and we have to figure it out. But if alpha is 0, the order of the accuracy, or the truncation error of this, is going to be order delta x squared. Okay, so this is how we find it. And now I want to answer this question: what is going to be the order of this approximation if alpha is not 0 and we are actually using a variable weighting scheme? And the answer is that it depends on alpha. Okay, so let's investigate that.